All right, so this is the day 2 review. We're going to go through this, and if people are gone, at least they can watch the screencast, understand how to do these problems. Awesome. Whether they'll watch it, TBA. Okay, to be seen. At least I'm trying. I'm doing every single thing I can to help people, including being here for bonus when people don't come to me. QQ. All right, chapter 7 review, day 2. Find the domain and range of the function. Okay, so domain, this is an exponential function. What's the domain of an exponential function? All real numbers, all real numbers. Hold the phone. What is going on here? This is x is greater than 0. Heck no. Heck no, tech no, x no. Okay, so we're at 50-50 shot. Now we got to think, what about y? Is this going to be above or below the asymptote? Roughly, what will this look like? Do I have an idea what this will look like if I graph it? Yeah, okay, what's it look like?
It's going to be 8 because it's 1
Yeah.
3, okay, so 1/5 to the x power is decay. So it's going to look like that, decay. But notice we are above the x-axis. So it's going to be b because y is greater than 0. Y is greater than 0. Notice my asymptote is at the x-axis. I don't cross it. Jonah, why are you back there? Why are you back there?
Because I need help.
Jonah, move back to where you're supposed to be. Move back to where you're supposed to be. So the all real numbers is the same thing as negative infinity to infinity. So clearly these are problems I got from the resource CD of the book. And then this one, y is greater than 0, or you could say 0 to infinity. So this is the domain, this is the range. Awesome. I'm going to try to put some multiple choice on there. As I said, like, multiple differences to an intermediate. I've been putting multiple choice on your past tests, so like, it's a pretty good indication. It's just hard because now this is where I get some of the multiple choice, so now I have to like make my own. I can just reuse these. Yeah. Yes, Matt. Exactly. It says x is only greater than 0, and so okay, saying x is greater than 0. Oops. Saying x is greater than 0 would mean I only have values on the right side, but that's false because look, I have some negative x values as well. So that's why they cross out. Okay, awesome. How do we feel about this problem? We know domain and range? Okay. Number 2, which function represents decay? So let's go through and let's explain why on each one. So here's the base. Growth or decay? Growth. Is this an exponential? Yeah, it is. Because I have a number as my base and a variable as my exponent. What about g? What the heck is this? I have x to some power. Like this is literally square root of 4x. This is not exponential at all. This is just square root of this is literally a square root function. So that's not even an exponential. What the heck? H. Aha, it's a fraction, right? It's a fraction, so it's decay?
No.
Let's see, what's wrong with this picture? 4/3 is larger than 1. So it's growth. It's larger than 1, so it's growth. Yay, nay. What's wrong? Yay, nay. Good hit. 4/3. If I give you 4/3 of a pie, bet you'd be happy. Yeah, because it's more than 1 pie. You can do fractions.
No.
Is the number on top bigger than the one on bottom? That's how you know if it's over 1. So if I had 1/3, 2/3, those numbers on top are smaller than the bottom, so you know it's less than 1. 4 is bigger than 3, right? The top is bigger than the bottom, so that's how I know this is bigger than 1. Yeah, which leaves us, I hope this is right. Okay, here I have 1/8 as my base, and that is decay. So the answer is J. Answer is J. Okay. You know who I'm dressed as today? You see my outfit? I am a 17-year-old from Nebraska. Not here, because if I was here, I'd be wearing like a midriff. I'd like stand up and be like, whoops, pull it down, and then it's like, ooh, look at me. Oh, and I would have like that booty shorts. Yeah. What? No. I'm screencasting this, Matt. You forgot. just play your song and like go. I'm out. All right. That was a great one. Okay, number 3. Let's do it. Let's do number 3. Where did you get that coat? I'm just concerned.
That's kind of funky.
All right, Macklemore. All right.
And I bought it.
Do you wear it for other occasions besides
I
prom?
wore it last year quite a bit.
Yeah, he did.
From a test. I hasn't made an appearance this year yet. It's $25. It's actually a bathrobe. I have the. I'm not
You should wear it. That'd make it even better. Oh my God. Okay, let's keep going.
Glasses in the pocket.
Wait, what do you wear?
Your nephew's glasses?
No, they're like fish. Look. Whoa.
That's wow. Wow. Okay.
Oh, this is supposed to be an ode to Hugh Hefner.
I got that. I got that vibe when you walked in. I knew exactly. You should walk through the teacher's lounge with that stuff on. Please. I would cry. I think I would cry of laughter. If you just like walk through and all the teachers are in there and just be like
So I have to get extra credit for this going soon. You're not a farmer. I'm the farm animal.
What do you mean a farmer?
She's giving us extra credit for farmers and farm animals, so
Why?
I actually have to walk through those. So I'm going to play my song.
Wait, why are you getting extra credit for that?
Because Mr. Brian's Jewish Joyce's a Jewish studies teacher, and we have her right after, so she said, "Oh, dressed up for this."
But like, why a farm animal? Is that has something to do with like Hakeem, Honan? What's his name?
No.
Hagnan? Haman?
Yeah.
Yeah. Does that have something to do with Haman?
I don't know.
Haman?
I don't know this guy's name. I'm sorry. Okay, let's keep going. Let's keep going.
Come on.
I don't know. I'm just trying to understand. I'm trying to understand prom, okay? Let's keep going. Use the equation of the exponential function for the graph. Passes through 0, -3 and 2, -48 to find the value of y when x equals 2. Okay, so this is the regular absolute exponential function. So I have 2 values. I need to solve for what b would be. So I know what's my initial value when x equals 0. What's my initial value? All right, Zach, put away your phone. Trying to be sneaky. I see you. All right, what's my initial value?
Y equals 0.
Yep, when y equals 0. I'm sorry, when x equals 0, y equals -3. So -3 a times b to the 0. What's b to the 0 equal to?
1.
So a is -3. Okay, and now I'm going to use this to find what b would be. Let me do it a different color so you can see. So I need to use this to find what b would be. So I have y is equal to -3b to the x. I'm trying to solve for b. So let me plug in this x and y coordinate. So -48 is equal to -3 times b squared. Okay, how do I get b by itself? Divide by -3. Divide by -3. Okay. So let's -48 divided by 3. Okay, what 4 divided by 3 is 1. 16 is b squared. How do I get b by itself? Square root both sides. So b equals 4. Okay, so what I need to do, this is like an in-depth problem. This is a good problem. On your test, you know, I would probably like give you like hint, use y equals a b to x. Okay, so what I need to do, so I'm going to write out the equation y equals -3 times 4 to the x. And I want to know what y is when x equals 2, so let me put in -2. -3 times 4 to -2. Same thing as -3 times 1 over 4 squared. Do you see how I got rid of the negative in the exponent by flipping 4 on the other side of the fraction? Exactly, -3 over 16. -3 over 16. So if you could get to like this point right here, plug into your calculator, because you will have your calculator for the whole test. So this is a good problem. This is positive energy. If you took it today, maybe you would have failed. But since you're going to be taking it Monday, positive thoughts, we're going through these problems. As long as you like review just a little bit yourself, like you will do better than you would have. So.
One issue with this costume is you didn't notice I got haircut.
I did.
I noticed. Jimmy, like, okay, let me pause class. Good haircut. Okay. Number 3, solve. Ah. All right, number 3, let's solve this. 4, number 4, you know, whatever, okay. 4 to negative 2x plus 4 plus 7 equals 3. Okay, you know what, I'm not going to rewrite it, whatever. How can I go about solving this, Matt? How do I go about solving this?
You find the first base.
Let's see.
2 squared and then 2 to no, that.
So my first thought was like to put both in 4, but like 4 times 4 is 16. Okay, so it's squared. 4 cubed, 16 times 4 is 64. Okay, so then I'd have to pick a base that maybe both of them go into. Yep, 2 to the 5th.
And then you have to distribute 5 to x minus 6.
And then the 2.
And it's so we got negative 4x plus 14 equals 5x minus 40.
Hold on, let me make sure I'm not going to try to skip a step. Hold on. I'm not going to skip a step. So, I'm not crossing out the 2. I'm literally, since it's the same base, I can set the exponents equal to each other. I'm not crossing out the 2. I'm setting the exponents equal to each other. Okay. So, negative 4 plus 14, negative 4x plus 14 equals 5x minus 40.
Then you subtract 5x. Then you add 14.
Subtract 14. So I have negative 9x minus 54 equals minus 54. Divided by negative 9.
And it's 6.
Whoop whoop, Jay, check it out. All right.
Wait, did you see the update calculator?
Nope, that's exactly opposite what I just said.
Wait, what?
You get a calculator for the whole test. So make sure you utilize it. Meaning, if you have a problem, go ahead. If I'm asking you to graph something, put it on your calculator. Did you graph it correctly? Do you know what an exponential looks like? Growth or decay? Alright. For instance, this one, I mean, if you had no clue, like figuring out, I'm like, okay, so 4, is 2 squared. That's an easy one. But if you're like, 32 is what power? Okay, well, 2 to the first is 2. 2 squared is 4. 2 to the third, okay, so times 2 is 8. To the fourth, okay, 2 times 8 is 16. To the fifth, 16 times 2 is 32. So I would find it that way. There's like little shortcuts you could use. Make sure you just like double check in your calculator. I'm giving it to you so you realize it as a resource. Alright, let's go ahead and let's solve this one. So this one's way trickier, but this is, it's kind of hard. Alright, Liana. The base? Okay, so 6. So negative 2 to the n power is equal to, let's see, 6 to the first is 6. 6 squared is 36. What's 6 cubed? 216. Okay, so that's one we're going to be using. Awesome, so I have 6 cubed to the n plus 5. So why am I writing it in the same base? Why do I want to do this? So I can set the exponents equal to each other. Exactly. Okay. Distribute, so I have 6 to the negative 2n, 6 to the 3n, plus 15. Since I have the same bases, I can set those pesky little exponents equal to each other. Okay. Minus 3n on both sides. Negative 5n equals 15. Divide by negative 5. I see n is equal to negative 3. Is that an option? CC! Okay. CC, senor. There we go. Alright. Let's do another. Did I give you 2 of those by accident?
Yeah.
No. Do you want an extra?
No.
No. Okay.
Listen, Brian, I need to go to the meeting.
Megala?
Yeah,
Okay.
I will watch this.
Yeah, you do you, man. Yes, Matt. Yep. Am I good to scroll down?
Yeah, I'm sorry.
Yeah, no.
Bases equal to each other.
Yeah, okay.
You gotta find a common number.
Alright, we're gonna set the bases equal to each other. Find a common number.
No, it is. I was like thinking 9.
It does.
Are you going to the amygdala as well?
I got -5 on my.
Yeah?
Yeah.
Are you leaving your stuff here? I'll take it with
Go to
you.
the bathroom and come back.
Oh, okay.
That's the-
Because I'm expecting you guys to actually go to the amygdala. I'm gonna check. I don't want you to go watching March Madness. I'm gonna check for the people who are gone. I'm gonna check where they were. All right. There is exactly. There is a sign-in sheet. No. Yeah. Thank you. All right.
So 3 is the base.
So what, Matt? You're gonna have 3 be the base.
Yeah. And then 9.
All right. So we found this one and this one. These are the 2 we're gonna use.
Yes.
Cool. So why am I, one more time, why am I finding a common base?
So you can set the exponents equal.
That way I can set the exponents equal. Exactly. All right, distribute.
4y and then 3y plus.
No, I can do this. Okay.
Shoot, okay.
Okay. Now you're gonna do some multiplication.
All right, since they have the same
You're gonna
base.
subtract the 3y,
Yep,
both sides, and then you got y is 9.
exactly. I'm thinking I put multiple choice for this one. Okay, awesome. Okay, so we've had a lot of practice solving like that. Let's go ahead, let's do the next one. Should be relatively quick, so Matt, I'll go ahead and give you a point because you've been like on the ball solving these problems. Yep, number 7. Sophie, take it away.
Okay, so the 1/4 to the 9 equals 6,561.
So I have, wait, what?
Yeah.
Write the equation in logarithmic form. So right now, this is the base.
Yeah, hold on. Okay, so yeah. Okay, so it'd be log 1/4.
1/4 is the exponent, so 1/4 belongs here. The base is 6,561, and then the result is 9.
Okay.
Because it goes log, base, result equals exponent. So this was the oops. So here, this is the result, so that's where the result goes here. This 6,000 was the base. And then I had my exponent was the 1/4 power. So which one doesn't match? B as in boy. Okay. Oh boy. All right. Oh boy, what kind of base is this? Let's go number 8. Evaluate. Rough stuff. All right. Think about how you would do this. And then we'll, yeah.
So 1/5 is from the log. So it's log base 5 63 to the power, right?
Mhm.
I just don't know where you go from there.
So this guy right here, if you have
Wait, doesn't
the
that
base to the power of log base a number, this, ooh, okay. All right, so this part like goes away and I'm left with the answer is just this number. So the answer is just gonna be 63.
Wait, why?
For instance, if I have like,
Is this the lesson I missed?
I have no idea. No, actually, this is 2, section 2.
Isn't this, wouldn't you put the, like,
No, this is,
wouldn't you put this 63 to the fifth power?
it's not 63 to the 5th power.
Where's that one?
Okay, so if I have, let's evaluate log base 5, 63. Let me evaluate this and show you how to do it. So first I'm going to take this top part, okay? I'll take this top part, I'll solve what the exponent will be, and then I'll plug in. So if I solve for this, I see 5 to the y equals 63. Okay. So when I evaluate log 563, literally what it equals is this y character. It's this y exponent, okay? So I'm going to replace this whole thing with just y. What is 5 to the y? 63. So when I evaluate it, I get an answer of 63. Okay, so it's a little like convoluted. Let's try it with like a little bit of an easier number. How about if I have like 2 log base 2 of 4? So we think right away, according to the rule, the answer should be 4. Let's double check that this is true. So first, let me evaluate log base 2 of 4. Okay, so 2 to the y power equals 4. What is this y going to be? Okay, so I'm going to replace this whole thing with just 2. So I have 2 to the second. What's that equal to? 4. Oh, so it literally goes back to itself. It's kind of like, it's a mirror. It's literally like talking. Okay, the exponent, log base of a number is giving you an exponent as the answer, and then I'm putting that base to that exponent, so I'm literally getting the result back. Okay. So if you have the same base and then log of that base as the exponent, you just have the other number as the answer. All right, let's try number 9.
My favorite.
Yeah, Chloe, you enjoy it?
Sure.
Heck yeah.
Okay, so you do the wheel, like, and it's just 1 get to the -1 with I. Then you put that into the calculator.
Or to the -1, how do I get rid of a negative and an exponent?
You flip it, so it's 5 over 1.
What's 5 over 1 to the first power?
5.
5.
Equals 5.
What you see?
Can you flip that?
To number 8?
Just like, so you then you just solve it.
Okay, Chloe, you want to explain it one more time?
Sure. So you do the wheel thing because you put the thing up to the log, you move it. You like you understand that part? Okay. So then you just kind of write that as equation, and then you just kind of just do 1/5 to the -1, which equals x, and then because you have the negative exponent, then you do 5 over 1 to that first power, which is equal to 5.
Questions? That was a good explanation. Just did the wheel. So I have a 5th to the -1 equals x. When I'm dealing with a negative exponent, you can get rid of the negative part by flipping the fraction. So instead of having 1 over 5, I have 5 over 1. 5 over 1 to the first power is just going to be 5 over 1. 5 over 1 is 5, and that's the answer. That's it.
Can I do number 10?
All right, yeah, hit it.
So basically, since the logs are equal, you set the equal to each other.
Exactly. We'll set the insides equal.
You do 5x plus 1 equals 3x plus 7. So you subtract the 3x from both sides, and then and then you subtract the 1 from both sides, so you get 2x equals 6, and you divide by 2x.
Awesome. Awesome. Questions? So when you have the same log base on both sides, you can set the insides equal to each other. Inside portion equal to each other. Cool? Let's see. All right, let's go on to number 11. Yep. Log 554.
And
Do like log base 5 of 2 and 7.
Okay.
And then you do the log each time, so it's log base 5 of 2 plus log base 5 of 7.
Okay.
So we know we log 2 1, so that's 0.4307 plus put the other in the calculator.
Well, we're supposed to approximate it using these two values. Can I change?
Okay, I need to do log base 5 of 3 times 9.
3 cubed?
And keep
Yeah. And then what? How do I get rid of that exponent?
4307 plus.
How do I get rid of the exponent?
What?
How do I get rid of the exponent? I have 3 to the third power. I need to move the exponent in front.
Yeah.
And then I can plug in my numbers, and then that's it.
Wait, why did it?
This is the power property of logs moving here. This is the product property of logs.
You just add them.
Then you add them. So what would that be equal to? Do I have my calculator? I do. $2.475? 785. All right, perfect. I'll trust you on that one. Wait, is this one of the answers?
Yeah.
Heck yeah, it is. Okay, blessed. We knew it was right then. All right. All right. Yeah. Move this up. All right, I want you guys to try number 12. I'll grab my charger from my computer, but then let's do 12. Let's keep chugging along.
So wait, remember to multiply, right? Yeah. Right, so you do n minus 3 times n plus 3. Yeah. Equals 2. Would you not?
All right. How are we doing with 12? Do you have an idea how to start? How do we start? How do we know what to do?
When you're adding, you said you multiply the 2.
Exactly. It's the product property of logarithms. Is exactly what we just used. The product property. So since I'm adding two logarithms, I'm going to be multiplying the insides together. So what this looks like is log base 4 of m minus 3 times n plus 3. All is equal to 2. Okay. So we can FOIL, let me just FOIL this bad boy out over here, m minus 3, m plus 3, so I have m squared minus 3m plus 3m minus 9. Okay, so middle 2 go away. So I have log base 4 of m squared minus 9 equals 2. I don't know, what do we do next?
You do the wheel.
Do the wheel? Alright, let's that's a really good idea.
Wait. Am I wrong? Do you know?
I told you it's a really good idea.
Oh, okay.
I didn't like it.
Whatever.
I don't. So that's 4 squared equals n squared minus n, and then it's
Minus 9?
minus 9.
Yeah.
And 4 squared is 16 equals n squared minus 9. And then
Okay.
you add 9. And then you do the square root of 1 at 25.
Yep, what do you get?
5.
Whoop, alright.
Because if you do this wrong, you get square root of 11.
Or
Ooh. Mm-hmm.
which I did. That's what
I do not do it wrong.
You just have to like follow through every step. This is also a reason why you show all your work, because then I'll see like, oh, okay, you did everything right. Like you just forgot your 2, you dropped it squared. That happens sometimes. I mean, sometimes I like drop things, but for the most part, as long as you're being like methodical, like clear.
So the log, it's log base 4 of m squared minus 9.
Mhm.
Got it.
Can you just put it in?
No, because your calculator doesn't know what the variable m is equal to. Yep. So that's why I was like, it's fine for you guys to use your calculator, because honestly what you'll use it as is to make sure you're doing your calculations correct. So you can check, right. So you can like double check that, like, 16 plus 9 is 25. Won't make you do that in your head, it won't slow you down. But yet it's not going to tell you the whole answer. You can't just plug in and do the whole solving. It's beautiful. Alright, let's do the next one. Ooh. Hold on. Did I have you guys do this one?
That was the last one, so yeah.
Is that where you're like,
Okay, you know what? Number 13 is actually not. This is one of the things I skipped with you guys. There's a good amount of stuff that I skipped that Algebra 2 does that we do not. 13 is one of them. This is not something I taught you. Sorry about that. Thought I cut out all the ones that didn't count. Alright. 14 we can do. This is what I thought was the problem. Alright, so we're going to solve this and we're going to round to the nearest 10,000th place. Okay, so ideas. Any idea how to start this? Huh?
You make 50 into a thing.
Well, let's see. So I'm trying to solve for things in the exponent. So I could
Oh, you try to get the exponent by itself.
try to get the exponent by itself.
And then you get that thing, and then you get exponent by that.
So in
So
order,
you-
how can I get like the base to cancel out? What can I do to have the base cancel out?
Make it in terms of time.
Yeah, so 5 to the
But it doesn't work.
log 5.
Log base 5 on both sides? Why am I having it as the base 5? Why am I having it be log base 5? Why not just like log base e? Why not natural log? Why am I picking 5 as the base? Because that's what the base is in my problem. Like, check it out. This is what the base is, so that's why I'm going to take log of that base on both sides. Why? So I can have that base cancel out in order to get this exponent by itself. Because I can follow the rule of logs. All right, I have this power property. All right, so I bring this out front. 2x plus 1 times log base 5 of 5. This is the whole reason I put it as log base 5 on both sides. I took each side and took log base 5 of it. Because log is a operation. Let me just copy over the right side. Log base 5 of 50. Okay. Because when I evaluate log base 5 of 5, what do I get? It goes to 1. Because really, what log base 5 of 5 is asking is, what exponent should I put 5, should I put as the exponent of 5 in order for it to equal 5? What power should I put 5 to in order for it to equal 5? Oh, the power of 1. The answer to logarithms are exponents. Whenever you evaluate a logarithm, you get an exponent as an answer. Whenever you evaluate a logarithm, like log base 5 of 5, we get an exponent as the answer. So here, I'm saying, okay, if I put 1 as the exponent, if I put 5 to the first, I'll get 5. That's true. That's why it cancels out. So I have 2x plus 1 is equal to log base 5 of 50. How do I get x by itself?
Subtract 1.
Subtract 1, 2x is equal to log base 5 of 50 minus 1. And then, get x by itself. Ugh, I got this multiplication still.
Divided by 2.
Divide both sides by 2. So I'll show you how to put this in your calculator. Log base 5 of 50, then minus 1 all over 2. So let me pull up the TI Inspire. It's loading. I'm also not going to have you do number 15. I mean, I could. Technically, I went over rules, change of base and logs, but I'm not going to have you do it. If you're doing trig and advanced algebra next year, you will be doing it. Oops. Okay. So what I'm trying to do is calculate. Calculate, enter, calculate. Okay, so what was the first thing? I wanted log base. Okay, so I have to do control, and then I click where it says 10 to the x, and then I can put in whatever base I want my log to be. So I log base 5 of 50.
Minus 1 divided
So it's not 50 minus 1, it's log base 5 of 50, then minus 1. Alright, so then I minus 1, and then that whole thing has to be divided by 2. So notice I put parentheses in order to have it so it will be divided by 2. I had to divide the whole thing by 2. So now this looks like what was on my paper. So when you plug in to evaluate, make sure it matches what's on your paper. So 0.51, let's see, 0.7153. 0.7153. 0.7513, is that what I said?
Yeah.
Perfect. All right, so we're not doing 15 because that's a change of base. I mean, I taught you, like I showed you that, but I'm not having you do it. What? What is it? 7153. Okay, thanks. All right, so 16. Suppose you deposit $1,000 in an account paying 3% annual interest compounded continuously.
Are we not doing 15?
Nope, we're not doing 15 because that's a change of base. Your calculator does the change of base for you.
Yeah.
Like I showed you how to do it, but I'm not going to like test you on it.
Oh, really?
But it's not on the test?
No, because your calculator can do the change of base. So I'm picking and choosing what I want you to like focus on. If you learn how to do it, cool. That may or may not be one of the bonus problems. So like if I showed you it, it's fair game for bonus, even if I'm not like specifically like testing you on it. Suppose you deposit $1,000. So this is going to be my principal. That's how much I'm depositing. That's my initial amount. Paying 3% interest. So this is my rate. How would I write this though? 0.03. Compounded continuously. Continuously means I'm not using the one with n. I'm going to use the one with e. Continuously tells you you're using the one with e. So I'll be giving you all the different exponential equations for your test, but you have to know how to differentiate between them. How do you know, like, when to use each one? You have to understand how to apply it, not memorize. I'm more about applying than memorizing. You need to know how to apply this. Use, oh my god, look what I said. Use a per, shoot, I told you even what to say. Okay, after 10 years is time. So I know P, I know R, I know T, I can plug in. A equals 1,000 times e to the 0.03 times 10. And what do I get when I plug that in?
13.
Alright, do you want me to show you how to put this on your calculator? Are we okay?
Yeah.
Alright, let's do it. Let's do it.
Is that all it is? Is that the answer?
Yeah, that's it.
Oh.
It's not bad. So did you see how much work? Oh, I'll go back to it in a second. Okay, so I have 1,000. So I put 1,000 times, and then there's this little E to the X button. So I push it. So I have it highlighted in red. You can find. Do you see where it says E to the X button on the bottom, like middle left? Push that, and it pops this up. And then you can put in 0.03 times 10. Enter gives you your answer. It's pretty beautiful. It's awesome. Look at that, doing the math for you. So what I'm expecting you to do is know how to use your calculator, because I will not tell you on test day how to do this, because I've done it every day in class. I've done it on the screencast. Do you see how I set this up?
Yeah.
So I wrote it. I listed out every single thing. Like I like circled and said, oh, here are all my values. Plugged it in. That didn't take me too long, right? This should be like a relatively quick question, but let's say you accidentally plug it into your calculator wrong. I want to give you partial credit. The more work you show, the easier it is for me to give you like some partial credit. Show me at least what you know so I can give you as many points as possible. All right, 17. No problems. Okay, so I don't have too many left. 17. Yep, so let's subtract 4 right away. So 3 times e to the 5x equals 24. Now what, Chloe?
E to the 5x equals 20.
Divide by 3.
8.
Okay, 8.
And then
No worries.
do 20.
What?
Yeah, that's
24.
But 27 is 24, it's 23.
Oh, why did I do this? Okay. That makes sense now. Sorry.
And then,
I should have put, I meant to do 24. My bad. Okay. It's fine. It doesn't matter. Calculator can do it. How do I get x by itself? Exactly. We want to take ln of both sides.
ln, and then ln.
So I have ln and e.
That cancels out, so it's just 5x equals ln divided by 5, and you get x equals ln 23 over 3 to 5.
23 over 3 all over 5. So if you put that in your calculator, what do you get?
You get max charging.
Okay. Yeah, definitely put your calculator in here and, charge it for a while. Charge your calculator. You need it for Monday.
I'm just surprised I actually know this stuff.
You guys are doing better today. So I'm going to show you how to plug this in. So if you push Control, then e to the x, you get ln. Control, then e to the x. So I have 23 divided by 4. Is that what it was? Divide by 3? Divide by 3? Divide by 3. And then I wanted to divide that whole thing by 2. 5. Divide by 5. Yeah? 0.4073. 0.4073. 0.4073. 0.4073. Okay. 0.4073. So it's like this is the closest one.
Yeah. Yeah.
Awesome. We're pretty good. We've gone through a lot today. Let's do 18. Let's do 18. So this is exactly like one that was on the practice test. So what do I want to do? How do I get rid of the ln? How can I get the x? Alright, so I have e to each side. So e to the ln of x plus 5 is equal to e to the 2. What happens to e and ln? Go away. X plus 5 equals e squared.
I just don't understand why, even if the element's x1, you can just get rid of it. 'Cause it's not really like.
So it's, okay, so I literally have e to the log base e of x plus 5. This is the same issue we had before. E and log base e, we just get this come down.
Why is it e squared?
So I put each side as like the power of e. So I have e to the second and e to the ln of x plus 5. Yeah, see, you guys got this. It's fine.
That's so e to the ln cancels out.
Yes, that's exactly why I did it, so I get an x by itself. Do I know what the value of this is?
Yeah.
What is it?
2.389.
Okay, awesome. We have 2 more. We've done a good amount of 2.389. I think we have like one more minute of class. Which one do you want to do? 19 or 20? 19? Okay.
So you do a half line.
Oh, I literally give you, okay.
So you do y equals,
Right, so I'm trying to find the half-life,
yeah.
and I gave you this equation.
So then you,
The a's cancel out.
that, yeah,
hmm
and you divide.
Well, if I'm trying to solve for something that's in the exponent, what can I do to each side? Because I want to get rid of this base of e. Take ln of both sides. So ln of 1/2. And when I take ln of this guy over here, ln and e cancel out, and I'm left with negative 0.0974t. And then to get t by itself, you'll just divide by the coefficient that's in front of it. ln of 1/2 over negative 0.0974. You said C? What number did you find when you plugged it in? 16.
7.1165.
Okay, cool. Okay, so we have like one more minute. I think we can do number 20 and then we'll be done. At a town with a large convention center, the cost of a hotel room has increased 5.1% annually. The average hotel costs $48 in 1990 and growth continues. What will the average hotel room cost in 2022? So I told you what to use. How nice. How beautiful. All right. So if I go from, let's see, 5.1 is my rate. So it's going to be 0.051. Right? Converting from percent to decimal, you move the decimal place over by 2. Yep. All right. So my initial cost is $48. How long is it between 2022 and 1990? It's 32 years. So y is equal to 48 times 1 plus. So I'm just plugging in the numbers that we found. So when you do this, let's see what you would get.
The hardest part of all these problems is setting it up.
Exactly. Exactly. Setting it up, knowing what to do first. So now you've had enough problems that you can like kind of get the gist of, if the problem looks like this is what you should do. If it's like this is what you should do. What did you get when you plugged it in? G, what you got exactly? So we round to the nearest cent. Cool, and then that's it. All right, have a good, I mean there is a bonus, but have a good Purim. So I'll just solve this one for the screencast. Since it's subtracting, it's going to be dividing. Log base 5 of 2x over x minus 3 equals ln e to the x plus 4. So that stuff cancels out. This cancels out. 2x over x minus 3 is x plus 4. Oh my gosh. Multiply by x minus 3 on both sides.
How much do you think it paid for the hotel, the last hotel room?
2x equals x squared. Minus 3x plus 4x minus 12. Let's see. Yeah, just a second. I'm going to finish this and then I'll upload it. Minus 2x on both sides, so 0 equals x squared minus x minus 12. We just have to, let's see, what multiplies to 12, adds to negative 1, negative 4 and 3. So I find that x can equal 4 or negative 3. Would this make sense? Could I plug this back into the original equation? See ya! I can't plug in a negative, so my only answer is x equals 4. So if I plug in a negative 3 right here, bad things happen. So I only have one answer, that's it.